Hey guys, this is page 319 of the Siegel book, and it's number 2. We're going to say an enzyme with a Km of 2.4 times 10 to the negative fourth was assayed at the following substrate concentrations. The velocity observed at 0.05 molar was 1.28 nanomoles per liter per minute. Calculate the initial velocities at the other substrate concentrations. What I'm going to do is I'm only going to do number A because number B, C, and all those other ones are the same exact thing. Okay. So the one I'm going to do is 2 times 10 to the negative 7th for that substrate concentration. So the first thing to do, most importantly, is to find my pencil, is to zoom out so you guys can see what I'm doing, is to write down your velocity equation. Right? It's going to be V equals SV max divided by Km plus S. Okay, so what they're asking for is what is your velocity? They don't give you your V max, but they do give you your substrate, Km, and they give you initial velocity for the very last one. So what that is 128 times 10 to the negative 9th moles. You want to make sure that everything is in the same molarity with everything else. And then your Km is 2.4. And your substrate is 0.05 moles. This is V max. This is 2.4 times 10 to the negative fourth. So this is the first thing that you have to do is you have to look at your equation and find out what you have, what you need to solve your equations. What we're going to need is we're going to need our V max. So we plug in what's given. And now all I'm going to do is I'm going to add these together and multiply and solve for V max. So now V max is going to equal 128 times 10 to the negative 9th times 0.05024. 1, 2, 3. Yep. Divided by 0.05. And so this is 0.2, basically this is 2.4 times 10 to the negative fourth added together. And so this bottom part is now up here. And this top part up here is now down there. This is what you should get. And let me try and give you an answer real quick. And we should be getting 1.28 or 1.29. So your V max is going to equal 1.29 times 10 to the negative 7th. Cool. Now they're asking, A through E are asking for all the velocities at certain concentrations. So the first concentration, number A, which is letter A, which is the one I'm going to be doing, the concentration they give you is 2 times 10 to the negative 7th. And all we're going to do is we're going to go back up here, take this equation, and plug it in. This right here is 1.29 times 10 to the negative 7th divided by 2.4 times 10 to the negative 4th plus 2 times 10 to the negative 7th. I'm going to pause this and I'm going to go ahead and get that calculation for you. Okay, now what I'm getting is the initial velocity for A after calculating all this should be 1.07 times 10 to the negative 10th moles per liter seconds. Let me make sure on those units. I'm sorry. This is not seconds, this is minutes. That's going to be the velocity. You're going to do the same exact thing for B, C, D, and E. E is already given to you, so you don't really have to do that. But there we go. That is number 2. Pretty simple. The main thing that you had to recognize is what you do and don't have. At the very beginning, they give you your S and Km, but they don't give you your V max. They want you to solve for your velocity. But they do give you your velocity for one of these substrates, for one of the many. Given that, you can find out your Vmax because Vmax and Km are always going to be constant for the same temperature, pH, enzyme, all that stuff. As long as everything's constant and the only thing that's changing is your substrate, your Vmax will be constant. If you're adding inhibitors or something like that, your Vmax will change. Well, not every single time, but it depends on what type of inhibition you have. But generally, yeah, if you're not changing anything and the only thing that's changing is substrate concentrations, your Vmax will be the same. Okay, I hope that helped out, and good luck on the final.